Hello everyone, welcome to Tutor ZM, and in this video we're going to be looking at tension. So let's look at the diagram that we have. So let's say this is a rope. This here is a rope, and let's say this rope is holding a block of mass essentially. So let's say this is a of mass, block of mass, BOM. Yeah, a block of mass. So what one thing that we need to understand is that we're looking at things in terms of physics. So we need to understand is that there is a force that is acting downwards upon the block of mass, and we know that that force is gravity. So we are going to have a force here acting downwards, and then we know that this force is is the weight or gravity. Weight and gravity one and the same thing, but in this context, let's call it the weight. So let's say the weight. Let me just redo the W. Yeah, let's say the weight, and then we know in physics weight is equal to the mass times the gravity. So tension, this is basically the force that is there in order to keep this block of mass in equilibrium. Down here, this isn't a rope, this is just representing the weight of the block of mass acting downward. So tension is needed, which will be above in the ropes. Tension will be felt, which I'm going to represent as capital letter T, in order to keep the block of mass in equilibrium, to make it not fall down due to the effects of gravity. So if this thing is in equilibrium, then one thing that we need to understand is that our tension will be also equal to our mass multiplying multiplied by gravity, because once we do that, they would cancel out. So let's say we had something else. Let's say this wasn't the case. So let's say this was not a block of mass. Let's say if this was an elevator. Let me just do that. Let me just quickly erase that. Yeah. So let's say this was an elevator, and we know that the main essence of an elevator is to lift people up and down, up and down. So let's say the elevator was going up. This elevator had to go up. So now, how will the elevator go up? What force is required? So notice that we still have our tension. We still have our tension. In terms of tension, we still have our tension. So let's say there was an acceleration, because the elevator experiences an acceleration in order for it to go up. So we still have our acceleration here. So then the tension in this case would be equal to mass and gravity. But if it were only equal to mass and gravity, implying that it would be in equilibrium, implying that the elevator would be still at one point, it wouldn't be moving if that were the case. So an extra acceleration is added, an extra force of acceleration is added. So plus, we know that force is represented by mass times acceleration. So in this case, then our tension, represented by T, would be equal to ma. This is mass times acceleration for force, will be equal to, as we were simply factorizing out, m, and then we'll have the gravity adding to the acceleration. So then this will be our tension for this case. So now let's say that, let's look at the shared scenario. These are the three scenarios that they give under tension, and it's very important understanding all three. Now let's say that this is still our elevator, and let's say the elevator was going down. It was accelerating downwards. Of course, we can't say that there is no tension, implying that the elevator would just free fall with gravity, and that would be very dangerous, because people would essentially, they might even die. Yeah. So let's say that the elevator is taking people down. What would be our tension in this case? So the tension will be the force needed to balance, to balance and then which would mean there shouldn't be an acceleration or the force that will essentially let off. So this is a simple key when it comes to tension. So it'll be accelerating downward. To be accelerating downward. So what we need is that our tension for the thing not to free fall, because the acceleration in this case will simply be the gravity will simply be gravity. So our tension will be mg, but in this case minus the force applied, which is sometimes referred to as gravity because it's falling downwards. So our tension at the end of the day will become mg minus a. So these are the three fundamental principles that one must remember every time when they're dealing with a question on tension. So it's as simple as that. This is just understanding how tension works and yeah, basically the physics behind it. So if you've enjoyed the video, please subscribe to the channel and I'll be seeing you guys in the next one. Thank you very much.